The final improvement to the simple Brayton cycle that we will take a look at will be one that will combine regeneration, which is what we just looked at, in addition to intercooling and reheating. Now, just like we said when we were talking about the regeneration, this is an addition that you would only do for ground-based stationary gas turbine, industrial gas turbine systems. So if you recall back in Lecture 9, Part 1, we talked about reversible work output for a steady flow device, and we came up with the following equation for reversible work output. So we had nu dP, and that was reversible work. So if we have a process whereby we're either doing compression or expansion, we can either minimize the amount of work that we have to do in compression or maximize the amount of work being produced by playing with the specific volume in this equation. So what we said is that what we want to do is either minimize the amount of work in a compression stage or maximize work output in a turbine. What we can do is we can adjust the specific volume. And so if we're in a compressor, that would be a case where we want to minimize the amount of work that we're doing. So the way that you can minimize the specific volume is by playing with the temperature. So if you move the temperature down or you cool the gas, then what that will do is that will minimize the amount of work that you're doing in compressing. And so that brings in the idea of intercooling that we will look at. And the other part is if you want to maximize work out, again, in that case, you want to move your specific volume up. And the way that you can do that is you can increase the temperature. How do you increase temperature? You go into what we call a reheat cycle. So intercooling can reduce compression work. Reheating can maximize turbine work output. So let's take a look at the process schematic and diagram for those two. It's going to be kind of a complex one because we've got a lot of stuff going on, but we'll work our way through it. So there is our process schematic, and you can see what we now have is multi-stage compression. So we have compressor 1, compressor 2, and we have multi-stage expansion, turbine 1, turbine 2. After the first stage of compression, what we do is we go into a cooling process in our intercoolers. So we're rejecting heat, cooling the gas, reducing the specific volume, then going into the second stage of compression. And then in the case of turbine work, what we are doing is we are going through a reheat process. And in the reheat process, we would add more fuel. We would then combust again, heating the gases up, and consequently that would then increase the specific volume, giving us more work coming out. And then finally coming out, we would then go into another regeneration stage, just like we did before. So that is a schematic of the process. The TS diagram, again, it's going to get a little crazy because we got a lot of stuff going on, but let's take a look at it. So this is our TS diagram. What we're doing, I'll walk you through this. We start at state 1, which is the gas coming into our compression So there's state 1. We then compress in the first compressor, taking us to state 2. On our schematic is there. We then go into an intercooling, so we're reducing the temperature of the gas. That brings us to state 3. We then go into another compression stage, taking us to state 4. We then go into combustion. So we do have reheat as well. And what I'll do, I'll draw the reheat here. If we're in an ideal world, it would take us up there, but in reality, we won't go that high because our regenerator would have some certain effectiveness. But we will go into a combustion process, taking us up to state 6 after combustion. We then go through the first stage of expansion through the turbine, taking us to state 7. We then do a reheat process, which is another combustion process, taking us to state 8. We then come through another turbine, taking us down to state 9. And then finally, we go into the regenerator and taking us to either 10 or 1 in terms of exhausting. So that is intercooling, reheating, regenerating, all with the Brayton cycle or the gas turbine cycle. The thermal efficiency of this cycle you would have to go through and calculate depending upon all of the different parameters that you might have. The other thing is that you could add many of these stages. However, the thing that you have to balance it with is the complexity and the increased economics and costs of having this type of design as a trade-off versus the increased thermal efficiency and reduced fuel savings that you may gain. So that would limit the number of reheat or intercooling stages that you might go through with a Brayton. But that is the Brayton cycle, and that will conclude today's lecture. Thank you very much.